So what if I told you that a 120-year-old cancer treatment, the sudden onset of multiple sclerosis, and like that slice of artisanal smoked salami in your fridge all share the exact same microscopic culprit?
I mean, it sounds like the setup to a really surreal joke,
Yeah.
but it is actually the foundation of one of the most radical, unified medical theories we have ever encountered in our source material.
Right.
Today, we are looking at a translated transcript from a highly speculative, deeply intriguing YouTube video. And this creator basically attempts to rewrite everything we know about how diseases mutate.
And before we get into the weeds of this deep dive, let's just be crystal clear about our mission today.
Definitely.
We're acting as your guides to unpack this creator's unique logical puzzle. We are absolutely not endorsing this as medical fact.
Right. Please don't throw away your doctor's advice.
Exactly. We are just examining this as a compelling thought experiment about how diseases might, interact in ways that modern medicine simply doesn't traditionally consider.
Yeah, and the entire theory really hinges on questioning established historical narratives.
Mm-hmm.
To understand the creator's perspective, we have to rewind the clock to the late 19th century. And we're focusing on a researcher named William Coley.
Okay.
So Coley was treating late-stage cancer using a concoction that became known in medical history as Coley's toxins.
Okay, let's unpack this. Because our source argues that the very name, Coley's toxins, actually represents a monumental misstep by the scientific community.
Yeah, a huge way.
And to appreciate the error, you need a vivid picture of what this concoction actually was. It was fundamentally an anti-erysipelas vaccine.
Right.
Erysipelas is a bacterial infection caused by Streptococcus, and historically they called it St. Anthony's fire.
Because it causes this intense, fiery red raised rash on the skin.
Exactly. But the medical establishment of the time categorized Coley's treatment merely as toxin.
Yeah, they focused on the toxic byproduct rather than the specific active bacterial source that was actually causing that fiery rash. And the source argues that by doing this, modern scientific medicine essentially went down the wrong path from day one.
They completely missed the point.
Right, they studied the chemical residue instead of the living biological agent doing the actual work.
It's like finding a key that miraculously opens a locked door. But instead of studying the specific shape of the key's teeth, which would be the erysipelas bacteria scientists, just melted it down to study the metal it was made of.
That's a great way to put it.
And the results Coley was getting with this key were just staggering. I mean, we are talking about an era with no antibiotics,
Yeah.
no modern cardiac support to keep a patient's heart beating through massive physiological stress. Yet this vaccine was yielding incredibly impressive results on stage 4 cancer patients.
And these were patients for whom the medical interventions of the time, like radical surgery or early rudimentary chemotherapy, were recognized as completely ineffective.
Or even worse, right?
Yeah.
Actively harmful. This source highlights that those conventional treatments often made the disease more malignant. Yet this anti-erysipelas vaccine was achieving a shockingly high percentage of remission in those exact same hopeless cases.
Which, brings up a glaring, really frustrating question. If it works so well, why isn't there a human vaccine for erysipelas today?
Right.
I mean, we get shots for tetanus, diphtheria, pertussis, but nothing for this specific streptococcal infection.
It is strange.
And when you look up the conventional medical explanation, say on Wikipedia, the claim is that an erysipelas vaccine just doesn't offer long-term or permanent immunity. The protection fades.
And the video creator finds that reasoning completely absurd.
Yeah.
Their argument is highly pragmatic. They say, well, even if immunity only lasts 1 or 2 months, that brief window of intense immune response was clearly enough to halt the progression of a deadly disease like stage 4 cancer in Coley's time. I have to agree with the logic there. I mean, if a shot gives me 2 months of protection and cures my stage 4 cancer, I will happily take that shot every 2 months for the rest of my life.
Absolutely.
And the source introduces this fascinating contradiction to highlight the missed opportunity. They say, look at veterinary medicine. Specifically, look at pig farming.
Yeah, human medicine abandoned this anti-erysipelas pathway entirely. Meanwhile, in agriculture, veterinary medicine successfully and routinely uses anti-erysipelas vaccines and serums for prevention and treatment in pigs every single day.
It really makes you consider why human medicine would throw away a pathway that veterinary medicine just went on to perfect.
It does.
And because that erysipelas vaccine was so shockingly effective at treating late-stage cancer, the source makes a massive causal leap. a true paradigm shift.
Yeah, this is the big one.
They ask, what if cancer isn't an arbitrary cellular malfunction? What if cancer is just a mutated form of the erysipelas streptococcus?
Right, and this is the core of their intelligent bacteria hypothesis.
Oh.
The source argues that 19th century medicine fundamentally lacked the tools like genetic sequencing or advanced microbiology to understand bacterial mutation.
So they just missed it entirely.
Exactly. They simply didn't grasp that the erysipelas bacteria could change its form so drastically to survive inside the human body.
So according to this theory, when this bacteria mutates, it splits down two distinct, mutually exclusive paths.
Right.
Path 1 is oncoerysipelas, which leads to cancers like bone sarcoma. And path 2 is dry internal erysipelas, which manifests as major neurological diseases like multiple sclerosis, ALS, and lupus.
And that concept of mutual exclusivity is really central to the creator's argument.
How so?
Well, they claim to have extensively scoured Russian medical monographs, looking through thousands of historical case studies and diagnostic records.
So if these mutations are genuinely mutually exclusive, then mathematically you would expect to never see a patient who has both a massive bone sarcoma and MS simultaneously.
Exactly. The diagnosis should always be singular.
Okay, but did they find any overlap?
The source claims that is exactly what the historical data shows. You have oncology or you have neurology, perhaps paired with general age-related organ weakness, but never a crossover of these major mutated states.
Wow.
And to the source, this proves the body only develops one specific mutation of this streptococcus at a time.
I have to channel some skepticism here, though, because it's the first thing jumping out at me.
Sure.
If this single mutating bacteria is the root cause of MS and cancer and lupus, why doesn't it show up on an MRI or a CT scan or a biopsy?
So question.
I mean, the source admits that modern lab tests only show inflammation, right? Like just the aftermath. They never show the bacteria itself. So how on earth is a bacteria hiding from modern medical imaging in 2026?
What's fascinating here is how the source resolves that tension. They theorize the bacteria has evolved into an intelligent bacteria.
Intelligent in what way?
In a biological sense, it means the bacteria has mutated to perfectly mimic human tissue. It alters its surface proteins, basically the microscopic ID badges it presents to the world, so that it perfectly matches the host environment.
Okay, so it's like a thief stealing a security guard's uniform.
Exactly.
The immune system is walking right past the intruder because it has the right ID badge on its surface. And I guess you can't biopsy what looks exactly like normal muscle or connective tissue.
Right, and this creates a diagnostic nightmare. The invisible bacteria can hide in different parts of the body, causing varied, migrating pain.
And the tests show nothing.
Right. The labs come back clean, the MRIs look normal, and blood work doesn't show a foreign invader. Doctors simply do not know what to treat because the clinical tests are entirely normal.
Tragically, this leads to patients being dismissed as hypochondriacs or simulators.
Yeah, it's awful.
But this brings us to a huge mechanical puzzle. If this bacteria is wearing a security guard uniform mimicking our tissue, how did Coley's vaccine actually defeat it? Like, why does shooting a patient with normal red skin-level erysipelas suddenly fix a stage 4 invisible mutation?
So the source breaks this down into a very specific biological battlefield.
Okay.
It's a three-step mechanism for how a stronger external infection basically strips away the camouflage of the hidden mutated one.
Let's logic this out. If you introduce a massive dose of aggressive, normal red erysipelas or an active vaccine of it, the immune system's immediate reaction is massive antibody production.
Exactly.
The body suddenly recognizes a severe, uncamouflaged threat.
And those new antibodies are designed to attack the fundamental structure of the streptococcus.
Right.
So because the hidden cancer, or MS, is just a mutated version of that same bacteria, the massive flood of new antibodies induces what we call cross-reactivity.
Ah, cross-reactivity.
Yeah, the immune response is so overwhelming that it looks past the stolen uniform, so to speak, and starts attacking the hidden disease too.
So you've got a flood of antibodies attacking both strains. But the body doesn't just rely on antibodies. The source mentions a second mechanism, comparing it to how penicillin works in a petri dish.
Yes, bacterial warfare.
Right.
The aggressive external red erysipelas bacteria literally competes with and crowds out the weaker mutated Oncostreptococcus.
So it starves it.
Precisely. The stronger, freshly introduced bacteria outcompetes the hidden one for basic biological resources within the body, starving it out.
Which perfectly explains why William Coley had to experiment to find the absolute deadliest, strongest strain of erysipelas to make his vaccine work.
He really did.
A mild strain wouldn't trigger the necessary biological warfare. It had to be aggressive enough to dominate the mutated cells.
Right.
And the body doesn't usually stop there when it's under attack, does it? Doesn't it spike a fever to burn them out?
Yeah, an active, massive spike in body temperature is the third weapon. This severe fever assists the body in destroying the weaker mutated bacteria that is already under attack from the cross-reactive antibodies and the competing bacterial strain.
Massive antibody production, brutal bacterial warfare for resources, and a boiling fever. It is a violent internal conflict.
Very violent.
But now that we understand the mechanics of the cure, we have to ask the most unsettling question. How is this shape-shifting bacteria getting into your body in the first place?
And the source points directly to your dinner plate.
Oh boy.
They draw a straight line back to the pigs. The connection here is entirely based on environmental triggers.
Okay.
In agriculture, pigs are known carriers of the erysipelas streptococcus. It exists in their blood, but it only flares up into an active, dangerous disease under very specific conditions.
And those triggers are stress, physical trauma like getting bruised in transport, extreme heat or cold, and intoxication, meaning, exposure to toxic substances or poisons.
Right. Now compare that to human medicine. The source points out an astonishing parallel. Modern oncology and neurology list those exact same factors as primary triggers for cancer flare-ups or exacerbations of multiple sclerosis and lupus.
Wow.
Stress, physical trauma, environmental extremes, and toxic exposure.
The exact same list. And the creator argues this isn't a coincidence, right? It's proof of shared pathology. They argue humans are being infected by eating pork.
They do.
But wait, I have to push back hard on this. Stomach acid is essentially a vat of hydrochloric acid with a pH between 1.5 and 3.5.
Highly acidic.
Yeah, it is designed to melt down and destroy pathogens. Are they really claiming that bacteria on a piece of undercooked pork just casually survives an acid bath?
They are, and the reasoning is a deeply ironic twist on modern food safety. The source believes that our food processing techniques are actually making the bacteria infinitely more dangerous.
Here's where it gets really interesting, because we usually think of preservation methods like salting, smoking, marinating as ways to kill bacteria. Right, think about a high-end deli aisle. You've got Jamon, raw smoked salami, cured bacon. We assume the heavy salt, the acidic marinades, and the smoke make the food sterile and safe.
But the theory proposes the exact opposite. Those extreme processing conditions act as a survival training ground.
A training ground?
Yes. Instead of dying, the erysipelas bacteria in the meat is forced to adapt. It thickens its cell walls, forms protective biofilms, and mutates into an ultra-aggressive extremophile before it ever enters the human gut.
So it's like a microscopic boot camp?
That's exactly what it is.
So by the time you eat that slice of smoked salami, the bacteria is already wearing physiological armor. When it hits the extreme hydrochloric conditions of your stomach acid, it's not destroyed because it already survived months of salt and smoke.
Right. It passes through, crosses into your blood or tissues, and begins that slow, hidden mutation process mimicking your cells.
Compound that with the reality of modern agriculture, too. Farm pigs are constantly pumped full of antibiotics, creating relentless evolutionary pressure for mutation within the animal itself.
It's a perfect storm.
So we are routinely manufacturing and ingesting highly resilient superbugs.
It is a terrifying mechanical sequence.
Yeah.
But the source argues this concept of animal-to-human bacterial mutation isn't just a modern industrial problem. It actually fits into a much larger, very ancient historical pattern.
Broadening the lens, this raises profound questions about zoonotic diseases, right? Illnesses that jump from animals to humans.
Exactly. The source reminds us that the species barrier is constantly being crossed. They point to recent examples like COVID-19 originating from bats.
Or historical plagues transmitted by fleas on rodents, camels, or hares.
Right. And to support this ancient pattern, the source points to dietary laws in the Bible, specifically the strict prohibitions against eating scavengers.
Like wolves, dogs, vultures, and eagles.
Yeah. The argument is that these ancient texts were not simply about spiritual purity or abstract morality. The source views them as early, practical epidemiological warnings.
Because the ancients didn't have microscopes to see bacterial cell walls thickening, but they saw the macroscopic results.
They observed the outcomes.
Right. They noticed that animals eating carrion dead, decaying flesh were harboring mutating dangerous